Is just a quick review of solving equations. Um, and the key thing to remember is once we have both sides simplified, so once we have simplified both sides, then we can go about the business that we actually want to do. And that is we want to isolate the variable. Now, when we are talking about isolating the variable, all that means is that we're going to get the variable by itself. So let's start off with a base example. And we would distribute that 5. We would have 5x plus 30 equals 10. Now, this left-hand side is simplified. This right-hand side is simplified. So I just need to work on getting the 5 by itself. And the way I do that is I kind of work backwards through the order of operations. So we do all of our addition and subtraction. We work with that. Then we work with our multiplication and division. So I have this 30 being added to this 5x. So we can subtract 30 from both sides of the equation. And if we do that, we end up with 5x is equal to negative 20. Now we deal with the multiplication and division. So this 5x, we divide both sides by 5, and we end up with x is equal to negative 4. And this is our final answer. Okay. We can always go back and check to see if it actually works. 5 parentheses negative 4 plus 6 close parentheses equals 10. Negative 4 plus 6 is 2. And 5 times 2 is 10. So we have 10 is equal to 10. Okay. So at this juncture, we know that we have done everything correctly. So let's look at this example. Now, the difference here is this example has a variable on both sides of our equal sign, meaning we're going to have to get all the variables to one side. We will deal with that momentarily. For now, let's just think about, are the sides simplified? The left-hand side, I can't reduce that down any. The right-hand side, I cannot reduce that down any. So now we work on moving all of our variables around. Now, we can either subtract 4x from both sides, or we can add 4x to both sides. I'm going to choose to add 4x to both sides here. And if we do that, we now have 21 is equal to 8x plus 21. Then we subtract 21 from both sides of the equation, and we get 0 is equal to 8x. Again, we subtracted this because we're moving backwards through the order of operation. Then we divide both sides by 8, and we have 0 is equal to x. We can go and we can check that works. 21 minus 4x, well, 4 times 0 equals 4 times 0 plus 21. And indeed it does. This becomes 0 and this becomes 0. So we just have 21 is equal to 21. Now, sometimes we will get special cases when we have multiple instances of our variable. And that kind of happens here. So let's look at what happens. We're going to do the same thing that we would always do. Is my left-hand side simplified down? No. So to simplify it, I multiply, or I distribute this 2. And that gives us 6x minus 12. Now, over here on my right-hand side, I have the same problem. I need to distribute. And I end up with 6x minus 12. Now, this is a special situation. Specifically, this is an identity. Meaning that no matter what value of x we put in, we will get a solution. So our final answer is actually that this is infinitely many solutions. But let's say that we did not identify that here. We're going to work backwards through the order of operations. First thing we need to do is we need to get all of our variables to one side of the equation. So I will subtract 6x from both sides of our equation, and we get negative 12 is equal to negative 12. The variable is no longer a factor. So we have 6x minus 6x, that goes away. We have 6x minus 6x, that becomes 0. Both of these become 0, leaving us with negative 12 equals negative 12. And if we have negative 12 is equal to negative 12, then we have a true statement. This is true. It will always occur, which is why this is an identity. Okay, that will do it for this video, and I will